The Appalachian Mountains of eastern North America and the Caledonian Range threading through Scotland and Norway share something that distance should make impossible: identical rock composition and identical mineral signatures, identical age, roughly 480 million years old. Separated now by 4,000 kilometres of open Atlantic, they were once a single ridge part of the same mountain system on a world we call Pangea, a world that has not existed for more than 200 million years. The detail is small, and it refuses to go away. What does it mean that the ground still remembers, not as metaphor, but structurally, chemically, in the grain of the rock itself? Those two mountain ranges do not resemble each other by coincidence. They were shaped by the same tectonic collision on the same supercontinent long before any ocean existed between them. Tonight we follow that memory through the geology, through the deep record of biology and climate, and through something harder to name: three traces moving slowly. What Pangea's record actually preserves, what the conditions of that unified first world may have made possible, and what the distance between those two mountain ranges still quietly asks. The room where you are listening is almost certainly colder or warmer than the deep interior of Pangea would have been. That interior, in places hundreds of kilometres from the nearest coastline, experienced temperature extremes no modern climate fully replicates. Heat built over land and remained without ocean water nearby to draw it back. Cold settled in without the softening influence of any maritime air. The dominant sound, if you could have stood there, would not have been waves. It would have been wind-long and hurried currents carrying fine mineral dust across distances that recognise no border we have ever named. Some of that dust settled into sediment. That sediment became rock, and some of that rock is still beneath the continents we live on now, distributed, sheeted, drifted apart, but holding the same mineral signature it carried before the world learned how to pull itself in two. This is where the scale of Pangea becomes difficult to hold correctly. We are accustomed to thinking of lost worlds as gone, erased, replaced, no longer retrievable in any form. But Pangea was not erased. It was redistributed. The ancient mountain routes of North America and Europe still align when mapped backwards through geological time. River deposits surface in places that by modern geography should share no common history. Genetic lineages divided by the Atlantic retain a shared ancestry that only makes sense if the land those organisms first evolved on was once continuous and unbroken. The world did not vanish. It scattered. And what scattered, if you follow it carefully enough, still points back toward a single origin. Here is where the record introduces a number that is difficult to sit with comfortably. Some of the coal extracted from the ground today was formed from forests that lived on Pangea roughly 300 million years ago. The trees that became that coal grew in an atmosphere with oxygen levels perhaps 30% higher than our own. They grew without any ocean between them, part of one vast interconnected canopy that stretched across a land so large that it had no real interior edge, only gradients fading slowly toward an inland silence. Those forests fell, were buried, and were compressed across a duration so immense that the number barely registers as time. 300 million years ago there was one forest. Now there is coal on 7 continents, each deposit carrying the chemical signature of the same ancient air. That is not a metaphor. That is a record. What the geological record preserves is one kind of testimony. There is another kind that this series has returned to carefully and without resolution across many episodes. On continents separated by the same Atlantic that divided those mountain ranges, cultures with no documented point of contact have preserved remarkably similar structures of memory. A world before this world, a catastrophic ending, a time when the boundary between sky and earth was arranged differently than it is now. Some researchers argue this convergence reflects shared human psychology, rather than shared human memory, that minds facing similar conditions will generate similar stories entirely independently, without any need for transmission or contact. That argument carries genuine weight, and we will hold it honestly tonight. It deserves to be heard as more than an obstacle. But it does not entirely account for the specificity of certain parallels. Some of these convergences are narrow enough and precise enough that parallel invention begins to feel like an answer that leaves the question still standing. Not proof. A pattern. And in this series, patterns are not conclusions. They are the shape of the question itself, the outline of something the record preserves without fully explaining. What Pangea was geologically is well understood. What it may have permitted across hundreds of millions of years of biological and climatic continuity is less settled, and what it might mean for the oldest structures of human memory, for the myths that reach again and again toward a world that ended before the one we know began, is a question the evidence does not resolve. It only keeps raising quietly in rock and gene and story alike. The mountain range on your side of the Atlantic is still there. So is its twin. Neither has moved in any direction a human lifetime could measure, but the rock remembers the angle of the collision that formed them, the pressure, the depth, the heat of a moment 300 million years in the past. Memory does not require consciousness. It requires only structure and time and something to hold the shape of what happened. So we follow the first trace into the ground itself, into what Pangea's deep record actually shows, and what it keeps suggesting when you look at it steadily, without urgency, in the quiet before sleep. A world before the word world. The two mountain ranges are still there, and that is worth beginning with before anything else is said. The Appalachians running along the eastern spine of North America, and the Caledonians threading through Scotland and Norway in a weathered, interrupted chain neither has moved in any direction a human lifetime could register, and yet the rock composing both carries the same isotopic signature, the same angle of tectonic formation, the same mineral memory of a collision that occurred when no organism with functional eyes yet existed to observe it. Geologists identified this correspondence in the 19th century, long before plate tectonics was accepted as the mechanism that could explain it, and the explanation once it arrived was both satisfying and quietly vertiginous. Those two ranges were once a single ridge built by a single collision on a single continent that has not existed for more than 200 million years. We named that continent Pangea, and in naming it we may have done it a subtle disservice. A name implies a thing that can be placed at a comfortable distance, examined, catalogued, filed correctly in a timeline, and left there. Pangea does not behave that way. It is not passed in any clean or settled sense. It is distributed, carried forward in stone that now sits beneath Edinburgh and beneath the hills of Virginia and beneath the floor of the Atlantic that divides them, still holding its formation angle, still chemically identical across an ocean that did not exist when it formed. What Pangaea was at its most basic geological description is this: a single continuous landmass covering approximately 30% of the Earth's surface, surrounded by one global ocean, Panthalassa, that wrapped around it without interruption in any direction. Its existence as a coherent, unified body spanned something in the range of 300 million years, from roughly 335 million years ago to approximately 200 million years ago, when the first significant rifting began along zones of weakness that would eventually open into what we now call the Central Atlantic. 300 million years is the duration the human mind accepts as a number, while almost entirely failing to feel as time. Every civilization we have ever named, every dynasty and empire, every written language, every monument and still standing, every piece of music ever composed, all of it would fit into a fraction of that span, so thin that if you drew Pangea's existence as a horizontal line across a wall, the entirety of recorded human history would not be visible to the naked eye at one end of it. This is not a rhetorical flourish. It is a genuine structural feature of the question we are following tonight, because duration at that scale changes what becomes possible. It changes what a landscape can accumulate. It changes what continuity means. The interior conditions of that world were unlike anything currently accessible to direct experience. With no Atlantic, no Pacific, no Indian Ocean, to circulate heat and moisture across the land, the climate deep within Pangaea operated according to physics that modern continental climates only approximate. Summer temperatures in the interior may have reached levels exceeding anything recorded in the Sahara or the Rub al Khali, sustained not by unusual solar activity, but by the simple absence of any nearby ocean to moderate them. Winter temperatures could fall with a severity that has no comfortable modern analogue in inhabited regions. The seasonal swings were structural rather than incidental. They were a direct consequence of a landmass so large, so far-reaching in its interior distances, that ocean air simply could not penetrate deeply enough to reset the temperature. The wind that moved across that interior had travelled for thousands of kilometres without touching salt water, without being humidified by any coastline, arriving mineral-laden and dry in a way that modern desert winds, which almost always originate closer to the sea than they feel, do not quite replicate. And yet, and this is where the geological record introduces a complication, the first description does not prepare you for Pangaea was not a barren world. Atmospheric oxygen concentrations during portions of its existence, particularly through the Carboniferous period that preceded and overlapped with its peak unity, may have reached levels roughly 30% higher than the air you're breathing now. Some estimates place the figure closer to 35% above current concentrations. The forests that grew in that enriched atmosphere were not forests in any sense we would find immediately recognizable. Club mosses reached 30 meters. Tree ferns spread canopies with no living equivalent. Seed ferns extended across floodplains that ran for distances no modern uninterrupted river system approaches. Those forests fell across millions of years, were buried by sediment, were compressed and chemically transformed across geological time into the coal seams that industrial civilizations have been extracting for 3 centuries. When a coal mine opens anywhere in Europe or in North America, or in parts of Central Asia, it is in a literal material sense opening a shaft into Pangaea. The carbon those seams contain was once atmospheric. It was once absorbed by trees. It was once part of a biological system operating at a scale of continuity that has not existed on this planet since the world began its long process of pulling itself apart. This matters for the question tonight, though this connection is not yet fully visible. The question stated, as plainly as it can be, is whether Pangaea's conditions, its vast biological and climatic continuity, its 300 million year span as a unified surface might have permitted something that our fragmented world has made structurally difficult, the slow accumulation of knowledge and practice across an unbroken landscape without ocean barriers, without the forced isolation that compels cultures to reinvent independently what other cultures have already learned. Not civilization in the sense of cities and administrative hierarchies, but something prior and more elemental, a coherence, a shared orientation toward the world. A condition in which, like an idea moving across a landscape, was not stopped by water. 3 traces will carry us through this. The first moves through the geological record itself. The second moves through biology, through the genetic signatures that continental drift scattered, but did not erase. The third is stranger and more contested, and we will arrive at it carefully. Each trace is partial, or, that is not an apology. Incomplete traces are the only kind the deep past offers. What we are following is not a proof, but a shape, the outline left by something the record keeps indicating without ever quite completing. The first trace begins where it must with the stone itself, and with what the stone has been holding across 4,000 kilometers of open Atlantic for longer than complex animal life has existed on this planet. What the leaf remembers. A pressed leaf fossilized in sandstone approximately 270 million years ago was pulled from rock in Antarctica in 1912, retrieved from an outcrop near the Beardmore Glacier by members of Robert Falcon Scott's polar expedition, among the last samples collected before the return journey that none of them survived. The leaf was from a plant called Glossopteris, a seed fern with a distinctive tongue-shaped frond and a pronounced central midrib that made it immediately identifiable to any paleobotanist who examined it. What made that Antarctic specimen significant was not its preservation, which was good, but not exceptional, and not its age, which was already known from similar deposits elsewhere. What made it significant was that identical Glossopteris fossils, the same species, the same morphology, the same structural detail in the frond had already been found in South America and Southern Africa, in peninsular India, and in southeastern Australia. 5 land masses, 5 locations separated from each other by some of the deepest and most continuous ocean water on the planet. 1 plant pressed into rock in all of them at the same geological moment. The distribution of Glossopteris was one of the observations that Eduard Suess, the Austrian geologist, used in 1885 to argue that the southern continents had once been connected, a unified landmass he called Gondwana, named after a geological province in central India where the fossils were particularly well documented. Suess did not have a mechanism. He proposed tentatively that land bridges had once connected the continents and then subsided beneath the ocean, which later analysis would show was physically implausible given the density of continental crust relative to the ocean floor. Alfred Wegener, working several decades later, proposed the correct mechanism that the continents themselves had moved and used Glossopteris as one of his central pieces of evidence alongside the matching mountain ranges and the corresponding geological strata. The scientific establishment rejected Wegener comprehensively for most of the first half of the 20th century, not because his evidence was poor, but because he could not explain what force was large enough to move continents. The force was eventually identified as mantle convection, the slow circulation of heat through the semi-fluid rock beneath the crust, powerful enough over geological time to carry entire land masses across the surface of the planet. Once the mechanism was confirmed, Wegener's observations and suesses before him became the foundation of modern plate tectonics. The Glossopteris distribution was not reinterpreted, it was vindicated exactly as stated. What this means in physical terms is straightforward to describe and difficult to fully absorb. Gondwana, the southern portion of Pangea comprising Antarctica, South America, Africa, India, and Australia, as a coherent unified block was a real place. It existed. Glossopteris grew across it as a single ecological system, its seeds dispersed by wind and animal and river across a land surface that had no ocean interrupting it. The plant did not cross water. It did not need to. The water was not there. What is now the South Atlantic, the body of ocean separating Brazil from Senegal at a minimum distance of roughly 2,800 kilometres, was at that time interior land, Gondwanan terrain, part of a connected surface across which the same fern grew in the same climate belt, depositing the same leaf shape into the same style of sedimentary rock on what would eventually become 5 separate continents. The ocean came later. The separation came later. The Glossopteris was simply growing where it lived on land that had not yet learned to pull itself apart. This is the first trace, and it is worth moving through it carefully, rather than quickly, because its implications extend beyond the plant. Glossopteris is one instance of a much broader pattern in the Pangean fossil record, the appearance of identical or near-identical species in locations that modern geography would make completely unreachable from one another, without oceanic crossing. Lystrosaurus, a stocky herbivorous reptile roughly the size of a pig, has been found in Antarctica, South Africa, India and China, all Pangean landmasses, all connected at the time of its existence approximately 250 million years ago. The Mesosaurus, a small aquatic reptile, appears in both Brazil and Namibia, and nowhere else in rock formations that match in age and depositional character across the South Atlantic. These are not coincidences of evolutionary convergence where separate lineages independently develop similar forms under similar pressures. These are the same organisms in the same rock on land that was once the same place. The ocean between them is younger than they are. What the geological and paleontological record establishes when assembled into a complete picture rather than examined piece by piece is something more significant than the existence of an ancient supercontinent, which is by now well understood and uncontroversial. It establishes that biological systems complex interconnected ecologically dependent networks of organisms operated at a continental scale for durations that dwarf anything that has existed since. The Glossopteris flora as a broadly unified ecological system persisted across Gondwana for something in the range of 50 million years. 50 million years of biological continuity across a connected surface with no ocean to interrupt dispersal, no water barrier to enforce isolation, no mechanism to prevent the slow diffusion of successful adaptations across the full extent of the land. What that kind of continuity produces in evolutionary terms is not uniformity. The fossil record shows regional variation within Gondwana local adaptation, distinct assemblages in different climate zones. What it produces is coherence, a living system that functions as a whole, that responds to disruption across its full extent, that carries genetic and ecological information across distances that after fragmentation become effectively infinite. The question that the first trace leaves open, not as a rhetorical gesture, but as a genuine unresolved feature of the record, is what that coherence permitted, that fragmentation ended. Not in biological terms, which are relatively well studied, but in terms of the slower, harder to fossilize processes, the movement of behavior of learned practice, of accumulated environmental knowledge across an unbroken surface. The Glossopteris does not answer that question. It only establishes, with the quiet authority of identical leaves pressed into rock on 5 continents, that the surface was once unbroken, and that what lived on it knew nothing of the divisions that would come later. The second trace begins from a different material entirely, and from a discipline that did not exist when Suess was examining his first Gondwana fossils. The map inside the body. Consider the lungfish, not as a curiosity of natural history, which is how it is most often presented, but as a problem, a quiet, persistent problem, that 3 separate continents have been generating independently for roughly 130 million years. The African lungfish lives in the freshwater systems of sub-Saharan Africa. The South American lungfish lives in the river basins of the Amazon and Paraguay. The Australian lungfish lives in the Burnett and Mary rivers of Queensland, the only surviving species of what was once a more diverse Australian lineage. All 3 are freshwater organisms. None can survive in salt water. None can cross an ocean. And all 3 are more closely related to each other genetically than any of them is to any other living fishes members of the same ancient order, Dipnoi, carrying a common ancestry that stretches back to a time when the rivers they inhabited drained into the same continental interior, and the ocean between their descendants did not exist. The lungfish did not cross the South Atlantic or the Indian Ocean. It was already on both sides before those oceans opened. What looks like a distribution problem, when examined through the lens of continental drift, resolves into something simpler and more vertiginous. The fish were not separated. The land was. This is the second trace, and it operates through an entirely different discipline than the first, where the geological and paleobotanical record speaks through rock and fossilized plant material. The biological record of Pangea's legacy speaks through living tissue, through DNA, sequences that carry embedded in their branching structure a map of ancient geography that no organism alive today has ever seen. The field that reads this map is called molecular phylogeography, and its central method is the comparison of genetic divergence times the point at which 2 related lineages last shared a common ancestor, estimated by measuring how much their DNA has accumulated differences over time. When those divergence times are calibrated and then mapped against the geological timeline of continental separation, the correspondences are not approximate. They are in a substantial number of cases precise enough to suggest that the organisms in question are separated not because of climate change or ecological pressure or random dispersal across water, but because the land they were living on was physically divided beneath them at a rate of centimetres per year across millions of generations until the gap became an ocean. The ratite birds are among the most studied examples of this correspondence. Ostriches in Africa, rheas in South America, emus and cassowaries in Australia and New Guinea, kiwis in New Zealand, the extinct moas of New Zealand, and the extinct elephant birds of Madagascar, all flightless, all large-bodied, all descended from a common ancestor whose lineage molecular analysis places in Gondwana before the separations began. The traditional explanation for their distribution proposed before molecular dating was available was that ratites had once been capable of flight and had dispersed across water to their current locations, to men subsequently losing flight independently in each location. The molecular data complicated that picture considerably. The divergence times between ratite lineages, as currently estimated, correspond more closely to the geological timing of Gondwanan fragmentation than to any pattern of overwater dispersal. New Zealand's Kiwi ancestors on the current best estimates were already in place before New Zealand separated from the broader Gondwanan mass. The birds did not fly there, the land carried them. Some researchers maintain that dispersal played a larger role than the molecular data suggests, and that argument is worth holding. Seriously, the calibration of the molecular clocks involves assumptions that are genuinely contested, and the dating uncertainties are real. But the overall pattern, the fact that flightless birds appear on precisely the land masses that were once Gondwanan in a distribution that maps cleanly onto the sequence of continental separation, is not easily dismissed as coincidence, even under the most cautious interpretation. What the biological record adds to the geological trace is something the rock cannot provide on its own evidence of living continuity. Fossils show that organisms existed across a connected surface. Genetics shows that the descendants of those organisms are still here, still carrying in their molecular structure the signature of a world that no longer physically exists. The African lungfish breathing air through to modified swim bladders in a drying river pool is not aware that it belongs to a lineage that has been present on that land surface continuously since before Africa. Was Africa, since before the South Atlantic existed, as anything more than a narrow rift valley, filling slowly with seawater? It is simply a fish doing what its biology permits, but its genome, when sequenced and compared to its South American and Australian relatives, describes a geography. It describes a continent. It describes Pangaea's southern half in the language of nucleotide substitution rates and branching chronology with a specificity and an internal consistency that the physical evidence of the rocks corroborates from a completely independent direction. The convergence of these two independent records, the fossil distribution mapped by paleontology and the divergence chronology mapped by molecular genetics, is the methodological foundation of modern understanding of Gondwana, and by extension of Pangaea as a whole. Neither discipline working alone could establish what both established further, that the current distribution of life on Earth is not the product of chance dispersal across existing oceans, but is largely the scattered remnant of biological systems that developed in full on a connected surface and were then carried apart by the same tectonic forces that moved the rock. The organisms alive today on the former Gondwanan landmasses are in a precise and non-metaphorical sense Pangean. Their bodies are the continuation of lineages that formed when those landmasses were one body. Their genetic divergence times are a record written in the language of evolution of when that body broke apart. What the second trace does not address, what it leaves deliberately open because the data does not reach that far, is what else might have been carried on those landmasses before the separation was complete. The lungfish genome records a geography. It does not record what moved across that geography, what was learned there, what accumulated across a connected surface over 300 million years of unbroken continental coherence. For that, the third trace moves into territory that the first two only gesture toward, into the oldest layers of human memory, and into the question of what those layers might actually be preserving. The memory that should not exist. Somewhere in the difference between 200 million years and 200,000 years, the third trace becomes difficult to handle with the same methodological confidence as the first two. The geological record and the genetic record share a common epistemological character. They are both material, both measurable, both subject to independent verification by researchers working from different starting points with different instruments. A fossil either matches across continents or it does not. A molecular divergence time either corresponds to the geological separation event or it does not. These are not such certainties, calibration errors exist. Interpretive frameworks matter. And the history of both disciplines contains revisions that demonstrate how much the initial readings can be wrong. But they are at minimum falsifiable. The third trace does not have that quality, and it is worth stating that plainly before going any further, because the temptation with this kind of material is either to dismiss it entirely or to weight it more heavily than it can bear. Neither response is honest. What the third trace offers is not evidence in the scientific sense. It is a pattern, a distribution of something across human cultures that, like the distribution of Glossopteras across Gondwana, raises a question the standard explanations address but do not fully settle. The pattern is this across cultures whose documented separation stretches back tens of thousands of years, and whose geographical isolation from one another was in most cases nearly complete, until the age of maritime exploration. There exists a recurring structural feature in the oldest recoverable layers of cosmological memory. That feature is the description of a world before this one, not a better world in a moral sense, and not a paradise in the conventional religious sense, but a world that was arranged differently, a world in which the boundaries that define present experience did not exist in their current form. The Hopi of the American Southwest preserve a tradition of previous worlds, each ending and giving way to the next, with the current world being the fourth in a sequence of fundamentally different arrangements of land, water, and sky. The Aboriginal Australian traditions of the dreaming describe a time of creation in which the land itself was shaped by ancestral beings moving across a surface that was not yet fully differentiated into the landscape currently inhabited, a surface in the process of becoming what it now is. The Mayan Popol Vuh, in its opening cosmological sections, describes previous attempts at creating the world, each of which was dissolved and replaced. The Vedic traditions of the Indian subcontinent carry the concept of successive world ages yugas, each differing from the others in fundamental characteristics of the physical and moral order. None of this is news to comparative mythology, which has catalogued these structural parallels for well over a century. The standard scholarly response to their distribution is the one that deserves genuine respect rather than rhetorical dismissal. Human minds facing the same existential conditions, the experience of seasonal death and renewal, the observation that landscapes change over long periods, the psychological necessity of accounting for discontinuity between past and present will independently generate similar narrative structures because those structures reflect the architecture of human cognition rather than the transmission of shared historical memory. This is a serious argument. It is supported by substantial cross-cultural psychological research. It explains a great deal of the convergence, and it would be intellectually dishonest to present it as merely a convenience deployed to protect an uncomfortable conventional picture. Carl Jung's work on archetype, Joseph Campbell's structural analyses of myth, Claude Lévi-Strauss's identification of deep mythological grammar. These are not trivial contributions, and the convergences they identify do not require a shared geographical origin to be real and meaningful. And yet the third trace is not simply about structural parallels in narrative form. It is about something more specific, and for that reason more difficult to fully absorb into the parallel invention framework. Across several of the oldest traditions, those with the deepest available archaeological context, those whose oral lineages can be traced back furthest through material evidence, the description of the previous world includes a specific and consistent geographical claim that the land was once connected in ways it is no longer connected. Aboriginal Australian traditions from coastal regions and the oldest continuously maintained oral traditions on Earth, with cultural continuity potentially exceeding 60,000 years, include specific accounts of land now submerged beneath the sea, accounts that in some cases correspond with measurable precision to the locations of drowned coastal shelves from the period of post-glacial sea level rise. These are not accounts of a metaphorical world. They are accounts of a physical place described in terms of landmarks that are now underwater, preserved across an oral tradition, long enough that the sea level change they appear to reference, which occurred between approximately 18,000 and 7,000 years ago, was transmitted through something in the order of 500 generations of human memory. Some researchers in the field of oral tradition and geological history, including Patrick Nunn and Nicholas Reed, whose work on this specific question was published in 2016, have argued that this correspondence between Aboriginal coastal traditions and documented seafloor topography represents genuine deep historical memory, not metaphor, not psychological archetype, but transmitted empirical knowledge of a landscape that changed. Their argument has been received with interest and some significant pushback within the relevant disciplines, and the debate is genuinely unresolved. This is the point at which the third trace complicates rather than confirms. If certain oral traditions can preserve specific geographical information across periods of 7 to 18,000 years, periods that in geological terms are extremely recent, then what becomes possible to ask about traditions operating across much longer timescales changes in character. The question is not answerable. There is no methodology currently available that could distinguish in a tradition 60,000 years old between information transmitted from direct observation and information generated independently by cognitive processes responding to universal human conditions. The absence of such a methodology is not a minor technical gap. It is a fundamental epistemic boundary. What lies beyond it, what if anything, the oldest human traditions might be carrying from direct experience of a world more connected than ours, cannot currently be seen. The third trace ends here, not because the question is resolved, but because the instruments do not reach that far. And that boundary, the precise location where the record stops yielding and the silence begins, is where the three traces considered together become something more than the sum of their individual evidence. The shape of a convergence. Place the three traces side by side, not as arguments stacked toward a conclusion, but as independent surveys of the same territory conducted by researchers who never consulted one another, using instruments that share no common components, working from material that does not overlap. The first trace speaks from rock from the isotopic chemistry of mountain ranges, separated by 4,000 kilometres of ocean from the pressed frond of a fern found in Antarctica, by men who were about to die from coal seams on 5 continents, whose carbon was once a single interconnected forest. The second trace speaks from living tissue from the genome of a freshwater fish that cannot survive salt water and yet appears on 3 continents whose connecting land vanished beneath two oceans from the divergence chronology of flightless birds, whose distribution maps onto the sequence of Gondwanan separation with a precision that chance dispersal across existing water does not adequately explain. The third trace speaks from memory from oral traditions old enough that some of what they describe can be corroborated against the physical record of landscape change, carrying within their deepest layers a recurring structural claim that the world was once arranged differently, that land connected what water now divides, that something whole was broken. 3 instruments, 3 materials, 3 methodological frameworks with no shared assumptions, and a single shape emerging from all 3 independently, from different directions at different scales of time. The philosopher of science William Whewell, writing in the 19th century, gave a name to the phenomenon: consilience of inductions. The word consilience derives from the Latin for jumping together, the idea that when independent lines of inquiry pursuing different questions through different methods arrive at the same point, that convergence is itself a form of evidence beyond what any single line could provide. Whewell was writing about the history of science, generally not about any specific discovery, but the concept has a precise application here. The geological record did not consult the genetic record when distributing Glossopteris fossils across Gondwana. The lungfish genome did not consult Aboriginal Australian oral tradition when accumulating nucleotide substitutions at a rate that places its Gondwanan ancestry before the South Atlantic opened. The traditions themselves did not consult the rock. Each record developed independently in isolation, carrying its own internal logic and its own sources of error. When they converge, not loosely, not approximately, but in their specific identifying features, the convergence carries evidential weight that exceeds the sum of its parts. This does not mean the convergence points to a true conclusion. Consilience is a condition for increased confidence, not a guarantee of correctness, but it does mean the convergence deserves to be examined as a convergence rather than as 3 separate claims, each of which can be addressed and set aside individually. What the 3 traces share examined together is not merely the general proposition that Pangea existed that is established independently by the geological record and requires no support from genetics or cultural memory. What they share is something more specific, the implication that the conditions of that connected world had consequences that outlasted the physical connection itself. The Glossopteris distribution outlasted Pangea's existence by 200 million years, preserved in rock that carried the plant's geographical context forward through time, even as the land it grew on moved to 5 separate locations. The lungfish genome outlasted Gondwana's fragmentation by 130 million years, preserving in its molecular branching structure a map of a landmass that no lungfish alive today has ever inhabited. The oral traditions, if Nunn and Reid's argument about the correspondence between Aboriginal coastal accounts and postglacial seafloor topography is taken seriously, outlasted. The specific landscape changes they describe by something between 7 and 18,000 years, a duration previously considered beyond the reliable reach of oral transmission, now requiring revision. All 3 traces describe not only what existed, but what persisted after it ceased to exist in its original form. They are records not only of Pangea, but of Pangea's aftermath of the long, uneven process by which a unified world left its signature in the material it left behind. The rehook that the convergence introduces is this: if biological continuity across a connected surface can imprint itself into the genome at a resolution fine enough to be read by molecular phylogeography 130 million years later, and if geographical knowledge of a specific coastal landscape can be preserved in oral tradition across 500 generations of human memory, then the question of what 300 million years of unbroken continental coherence might have imprinted into the deepest structures of accumulated human practice, not as mystical inheritance, but as slow, generational, materially grounded learning. Across a surface with no ocean barriers is not obviously answerable in the negative. It may not be answerable at all with current methods, but it is not the same question as asking whether continents were once connected, which has a clear answer. It is asking what that connection made possible across the full duration of its existence in terms of that the rock and the genome and the tradition each gesture toward from their different positions without any of them being able to complete the description on their own. The 3 traces held together produce a picture that is genuinely more than any one of them alone, but it is a picture with significant gaps, significant sources of uncertainty, and at least 3 serious objections that have not yet been addressed. That the consilience is real does not mean the interpretation of what it points toward is secure. The geological record establishes Pangea. The genetic record establishes biological continuity across Gondwana. The cultural record establishes something that may be deep historical memory, or may be the universal architecture of human cognition, generating similar forms under similar pressures, independently on separate continents. The difference between those two interpretations is not a minor technical detail. It is the difference between two fundamentally different accounts of what human memory is and what it can hold. That difference requires its own examination, careful, fair, and willing to sit with the possibility that the most parsimonious explanation is also the correct one. What the simpler explanation says. The simplest explanation for the convergence described in the previous chapter is not a conspiracy of suppression or a failure of scientific imagination. It is something considerably more mundane, and considerably harder to argue against, that the human mind is a pattern recognition system operating under conditions that reliably produce false positives, and that the cultural and cognitive parallels identified across separated traditions reflect the universal architecture of that system, rather than any shared geographical experience. This is the mainstream position in comparative mythology, cognitive anthropology, and the psychology of religious experience, and it is held by serious researchers working from substantial empirical foundations. It deserves to be presented as what it is: not a defensive maneuver, not an institutional reflex, but a genuinely well-supported account of why the convergences exist that requires no appeal to deep historical memory, shared ancient experience, or any version of the proposal that Pangea's conditions left traceable consequences in human cultural transmission. The case for this simpler explanation is strong enough that any honest treatment of the third trace must begin here, with the objection at full strength before noting what it leaves unaddressed. The first and most substantial objection concerns the mechanism of the third trace itself. The claim that oral traditions might carry specific geographical information across periods of 7,000 to 18,000 years, the Nunn and Reed argument about Aboriginal Australian coastal accounts rests on an assumption about transmission fidelity that is not well established across that timescale. Oral traditions are not inert containers. They are living socially embedded practices that are continuously reinterpreted, selectively preserved, adapted to new social contexts, and inevitably shaped by the cultural pressures of each generation that carries them forward. The telephone game problem, which any researcher in oral tradition will acknowledge, compounds across 500 generations in ways that make the surviving content an uncertain guide to the original content. The correspondences between certain Aboriginal coastal accounts and the documented topography of drowned continental shelves may reflect genuine transmitted memory of specific landscapes. They may also reflect the fact that oral traditions operating in coastal environments will naturally describe the sea as having once been land, because in most coastal environments the sea has in fact advanced over previously habitable terrain during the post-glacial period. And communities living in such environments would observe this process, incorporate it into their narratives, and produce traditions that coincidentally correspond to geological reality, without requiring continuous transmission from the original event. The correspondence is real. The interpretation of what produced it is not settled. The second objection concerns the comparative mythology argument more broadly, the structural parallels between traditions describing a previous world, the Hopi Four Worlds framework, the Vedic Yuga system. The Mayan successive creations are striking when listed together, and considerably less striking when examined in the full context of each tradition's internal logic and the specific cultural conditions that shaped it. The concept of cyclical time of worlds ending and being replaced is a natural cognitive response to the observable fact that landscapes change, that catastrophes occur, that previous human communities leave visible evidence of their existence in places that are no longer habitable. Every culture that survives long enough and pays sufficient attention to its physical environment will generate narratives accounting for discontinuity between past and present, that these narratives share structural features, a previous arrangement, a disruption. A current diminished state may reflect nothing more than the fact that the underlying experience they are processing is genuinely universal. The world was different before, and something changed it. This is not a mythological claim. It is an empirical observation that any observant community will make, and the narratives it generates will necessarily share structural features with narratives generated by other observant communities without any transmission, between them being required. The third objection addresses the consilience argument directly. Whewell's concept of consilience of inductions is a genuine epistemological principle, but it carries a critical limitation that its enthusiastic applications sometimes obscure. Consilience increases confidence in an explanation only when the independent lines of evidence are genuinely independent, and when the explanation being tested is the simplest one that accounts for all of them. In the case of the three traces considered here, the simplest explanation that accounts for all three does not require any appeal to Pangea's civilizational potential to deep cultural transmission, or to consequences of continental coherence beyond the biological and geological. It requires only plate tectonics, which explains the geological and fossil record completely combined with evolutionary biology, which explains the genetic distributions completely combined with cognitive universalism, which explains the cultural parallels without any residue. Three well-established frameworks, each independently supported by extensive evidence in its own domain, each explaining its portion of the convergence without reference to the others. The consilience on this reading is not evidence of a deeper unified explanation. It is the appearance of consilience produced by three separate, already explained phenomena being grouped together and examined as if they constituted a single problem. These three objections are genuine. They are not rhetorical obstacles to be cleared away. Each of them represents a position that a careful, well-informed researcher could hold without intellectual dishonesty, and the weight of established scholarship in the relevant discipline sits on balance closer to these objections than to the interpretation the three traces taken together suggest. And yet stated carefully, without overclaiming each objection, addresses its assigned portion of the convergence and leaves a remainder. The cognitive universalism account explains why separated traditions would independently generate narratives of a previous world. It is less directly explanatory of why certain traditions appear to carry specific geographical information, not structural narrative but locational detail that can be corroborated against independent physical records of landscape change. The oral transmission fidelity objection explains why such information would be expected to degrade across 500 generations. It is less directly explanatory of the cases where it appears not to have degraded, or where the correspondence with physical evidence is specific enough that degraded transmission would not be expected to preserve it. These are not conclusions. They are observations about where the simpler explanations reach ends, and where the question continues beyond it not resolved, not confirmed, but still open, in the particular way that genuine unresolved questions remain open, which is to say patiently and without urgency, and without any clear indication of when an answer might arrive. What remains after the objections are applied? The three objections presented in the previous chapter do not cancel the three traces. That is the first thing to establish clearly, without defensiveness and without the kind of rhetorical recovery that acknowledges criticism only to immediately restore the original claim at full strength. The cognitive universalism argument is correct in its domain. The oral transmission fidelity objection is correct in its domain. The consilience limitation argument is correct in its domain. Applied honestly, they reduce the evidential weight of the third trace substantially. They introduce genuine uncertainty into the interpretation of the cultural convergences, and they establish that the simpler explanation plate tectonics plus evolutionary biology plus cognitive universalism accounts for the majority of what the three traces describe without requiring any additional framework. This is a real reduction. The picture that remains after the objections are applied is smaller, less dramatic, and more uncertain than the picture before them. That is what honest engagement with serious objections produces, and the reduction should be accepted rather than explained away. What the chapter that follows, a genuine skeptic chapter, must do is not restore what the objections removed. It must identify carefully what the objections did not remove, what remains in the traces after the strongest available counterarguments have been applied at full force, and ask whether that remainder is significant enough to continue following. What remains is this, a question about scale and duration that the three established frameworks taken together do not fully address. Plate tectonics explains the distribution of glossopteras across Gondwana completely. Evolutionary biology explains the lungfish genome and the ratite bird distribution completely. Cognitive universalism explains the structural parallels between separated traditions, accounts of previous worlds plausibly, and with substantial supporting evidence. None of these frameworks, individually or in combination, is specifically designed to address the question of what 300 million years of biological and climatic continuity across an unbroken continental surface accumulates not in geological strata, not in genetic sequences, but in the slower, materially grounded processes by which organisms, and eventually organisms capable of learning and transmitting learned behavior, orient themselves to a landscape across generational time. This is not a gap that the established frameworks have examined and found empty. It is a question they were not built to answer, because the question itself sits at an intersection that the disciplinary boundaries of geology, genetics, and cognitive anthropology do not naturally span. The absence of an answer from those frameworks is not evidence that the answer is negative. It is evidence that the question has not been directly addressed by the methods available. The researcher Robin Wall Kimmerer, working at the intersection of indigenous botanical knowledge and Western plant ecology, has documented in detail how plant communities in North America carry ecological information accumulated across generations of close human observation, information about species behavior, seasonal timing, soil conditions, and interspecies relationships that Western botanical science, working from a much shorter observational baseline, had not independently recovered and in some cases had not considered. The knowledge she documents is not mystical. It is empirical, accumulated through sustained methodical attention to specific landscapes across periods of time that Western scientific observation of those same landscapes does not approach. Kimmerer's work is not about Pangea. It is not about deep time or continental drift or the origins of civilization, but it describes a principle that is directly relevant to the question the three traces are circling, that the duration of observational engagement with a landscape is itself a form of knowledge infrastructure, and that this infrastructure accumulates at timescales and in forms that standard epistemological frameworks do not routinely account for. 300 million years of biological continuity across a connected surface is not the same as 300 years of indigenous ecological observation in a specific forest. The scales are incommensurable. But the principle that duration of engagement with a continuous environment accumulates something that shorter engagement does not operate across both. This is the reframing that the recovery chapter requires, and it is important to be precise about what it does and does not claim. It does not restore the third trace to the evidential status it had before the skeptic chapter. It does not propose that oral traditions preserve direct experiential memory of Pangea, or that human cultural practice carries traceable inheritance from conditions that ended 200 million years before anatomically modern humans existed. Those claims are not supportable and are not being made. What the reframing does is shift the question from a historical claim. Did Pangea support something that deserves the word civilization to a structural one? What does a world without ocean barriers permit in terms of the slow accumulation of orientation across a connected surface that a fragmented world does not? The structural question does not require the third trace to be evidentially robust. It requires only the first two traces, which are not seriously contested, that biological systems operated at continental scale across Pangea's connected surface for durations that dwarf anything that has existed since, and that the consequences of that operation are still readable in living tissue and in rock. If biological continuity of that duration and that geographical extent leaves traceable signatures in genomes and in stone, the question of what else it might have permitted, in terms of the slower, less fossilizable processes of accumulated environmental orientation, is not obviously answerable in the negative, even after the skeptic chapter's reductions have been honestly applied. What the recovery does not do is claim that the remainder after the objections are applied constitutes proof of anything. It constitutes a question that the available evidence raises without resolving a question whose shape is clearer for having been examined from both directions through the traces and through the objections, and whose genuine difficulty is now more visible than it was before either examination began. The Appalachian and Caledonian mountain ranges, separated by 4,000 kilometres of Atlantic, are still made of the same rock. The lungfish genome still describes a landmass that no lungfish alive has ever seen. Whatever the third trace ultimately means, whether it describes genuine deep transmission, or universal cognitive architecture, or some combination of both, that current methods cannot distinguish the first two traces establish without serious remaining contest that the world was once connected in ways that left consequences still readable in the present, The question of what those consequences include beyond what geology and genetics have already mapped is what the next chapter begins to examine from a different angle entirely. The eighth trace, which is not a new trace but an extension of all three, into a domain. The previous chapters have not entered concerns, not what Pangea left in rock and genome and tradition, but what the structure of a connected world makes possible for any sufficiently complex organism operating within it, across sufficient time, and whether anything in the current distribution of human cognitive capacity might carry the shadow of that structure forward into a world that no longer remembers physically what it was like to be a whole as the architecture of orientation. A songline in the tradition of many Aboriginal Australian peoples is not a song in the sense that the word carries in any European language. It is a navigational system, a mnemonic archive, and a cosmological map, simultaneously a sequence of sung descriptions encoding the physical features of a specific route across the landscape in sufficient detail that a person who knows the song can travel the route without having previously walked it, recognizing each geographical feature as it appears by its correspondence to the verse that names it. The routes encoded in songlines cross the Australian continent in networks of extraordinary complexity, connecting sites separated by hundreds of kilometres through chains of sung descriptions so precise that researchers in the late 20th century, working with both Aboriginal knowledge holders and topographic survey data, found consistent correspondence between the geographical features named in the songs and the actual features of the terrain. The accuracy was not approximate. In documented cases, features described in songs whose age cannot be precisely determined matched specific rock formations, water sources, and landscape contours with a fidelity that excluded the possibility of coincidence. The songs were not poetry describing a general landscape. They were, and in living traditions continue to be, functional navigational instruments encoding specific physical information about a specific surface transmittable across generations, in a form that preserves operational detail across timescales that written navigational charts in Western tradition do not approach. The songline system is relevant to the question the previous chapter opened: what a connected world permits for complex organisms operating within it across sufficient time, not because it is ancient in a way that connects it to Pangea, which it is not, but because it represents an extreme development of a cognitive capacity that is universal in anatomically modern humans and varies dramatically in its elaboration depending on the character of the environment in which it develops. That capacity is landscape memory, the ability to encode, transmit, and operationally deploy detailed spatial information about a physical environment across generational time. Every human culture with a long relationship to a specific landscape develops this capacity to some degree. The songline system represents its development in an environment characterized by vast continuous terrain, minimal ocean interruption, and a cultural history of sustained engagement with a connected surface across a period that, while not approaching geological scale, is among the longest available for study. What the songline system demonstrates is that sustained engagement with a continuous landscape across sufficient generational time produces navigational and spatial cognitive systems of a sophistication and a precision that engagement with a fragmented landscape, one interrupted by ocean, by enforced isolation, by the cognitive effects of bounded horizons, does not independently generate at the same scale. The landscape shapes the cognitive instrument that orients to it. A connected landscape engaged across sufficient time shapes a connected cognitive instrument. This is the expansion the eighth chapter acquires from the question of what Pangea left in rock and genome and cultural memory to the question of what the structure of a connected environment produces in terms of the cognitive and orientational capacities of the organisms that inhabit it, as a direct consequence of the environment's structural character, rather than of any specific transmitted content. The lungfish genome carries Gondwana's geography not because any lungfish consciously remembered it, but because the genetic divergence process is itself a form of environmental encoding. The branching chronology of the genome is shaped by the geography of the land. The organism's ancestors inhabited passively structurally as a direct consequence of what the environment was. The songline system carries the Australian landscape not because any individual singer chose to preserve it, but because the cognitive demands of sustained orientation across a vast connected terrain shaped a mnemonic system capable of meeting those demands across generations of use into a form whose precision reflects the precision of the landscape it encodes. Both processes, genetic encoding and cognitive encoding, are shaped by the environment without requiring any agent within the system to intend the encoding. The environment writes itself into the systems that navigate it, at whatever timescale and in whatever medium those systems operate. The question this raises about Pangaea is not whether any organism living on it consciously preserved information about its connected character, or whether any tradition traceable to that period survives in legible form today. Those are the wrong questions, and they produce the reasonable objections the 6th chapter addressed. The question is structural. What does 300 million years of sustained biological operation across an unbroken continental surface without ocean barriers, without the cognitive and evolutionary effects of enforced isolation produce, in terms of the orientational systems of the organisms that develop within it? Not in any specific organism, not in any specific tradition, but in the general character of the cognitive and behavioural repertoire that emerges from that environment as a condition across the full duration of that condition's existence. The Permian period. The final chapter of Pangaea's coherence, spanning roughly 50 million years before the mass extinction event at its close, was the period during which the earliest mammalian ancestors, the therapsids, developed and diversified across the connected Pangaean surface. The cognitive and sensory systems that would eventually, across 250 million years of subsequent evolution, produce the human brain began their development on a connected continent, in an environment where orientation across vast continuous terrain was a primary survival challenge, without the cognitive simplifications that ocean barriers introduce by making large portions of the world's surface permanently unreachable and therefore cognitively irrelevant. Whether that origin leaves any traceable signature in the current architecture of human spatial cognition is not a question current neuroscience is positioned to answer definitively. The field of evolutionary cognitive science can identify the broad conditions under which specific cognitive capacities are likely to have been selected for, but the resolution available does not extend to distinguishing between cognitive systems shaped by connected Pangaean terrain and cognitive systems shaped by the fragmented post-Pangaean world in which most of subsequent mammalian evolution occurred. What it can establish, and what the songline parallel illustrates from a different direction, is that the character of the environment and the character of the cognitive systems that orient to it are not independent variables. They develop in relation to each other at whatever timescale the relationship operates. The environment is not a neutral stage on which cognition performs. It is a shaping force writing its structural features into the systems that navigate it across whatever medium and whatever duration those systems permit. The 9th chapter does not continue this argument toward a resolution. It arrives instead at a detail in the record that the argument cannot account for a pattern that none of the 3 traces and none of their extensions fully explains, and that sits in the evidence with a specificity that outlasts every framework brought to bear on it. The suture line. On the southern coast of South Africa, approximately 300 kilometres east of Cape Town, a cave called Blombos opens toward the Indian Ocean from a limestone cliff roughly 35 metres above the current sea level. Inside it, excavated from occupation layers dated to approximately 100,000 whole years ago, archaeologists recovered 2 small pieces of ochre iron rich stone ground to a flat surface and engraved with a crosshatch pattern of deliberate parallel lines forming a geometric design. The lines are not random marks. They are consistent in their spacing and angle in a way that excludes accidental production. They require sustained attention, a held intention, and a material understanding of how to work ochre against a harder surface to produce controlled marks. They are, by the current consensus of the researchers who have examined them, the oldest known evidence of deliberate symbolic marking by anatomically modern humans. The earliest recoverable indication that a human being looked at a surface and chose to impose a pattern on it for a reason that was not purely functional. 100,000 years ago, on the southern coast of Africa, on a rock formed in Gondwana. The Blombos cave is the specific detail that no single framework fully accounts for, and the reason requires some care to articulate precisely, because the cave itself, its ochre engravings above, its shell beads and its heat-treated stone tools is well documented and uncontroversial within paleoanthropology. What is less discussed and what sits at the intersection of several independent lines of evidence without any of them completing the picture alone is the geological character of the location and what it represents in the deeper record. The southern African coast where Blombos sits is not arbitrary terrain in the Pangean context. It is a Gondwanan suture zone, specifically part of the coastal margin that formed when the supercontinent's southern components began their separation, when the Indian Ocean began opening between Africa and what would become Antarctica and Australia. The rock itself, the limestone of the cliff containing the cave, formed in shallow marine conditions during the early stages of that separation. The land on which the oldest known symbolic human behaviour occurred is in a direct geological sense a scar from Gondwana's fragmentation, a place where the connected world tore itself open and the ocean entered. This would be an interesting coincidence if Blombos were an isolated data point. It is not. The broader southern African region, the Cape Floristic region, the Karoo Basin, the coastal zone extending from the Western Cape eastward into what is now KwaZulu. Her natal contains not only the highest concentration of early modern human archaeological sites in the world, but also the oldest genetic evidence of the deepest human population divergences. The San peoples of southern Africa carry in their genomes the deepest branching lineages of any living human population. Their genetic separation from all other human groups is estimated by multiple independent molecular dating analyses at between 100,000 and 150,000 years, corresponding to the period during which Blombos and contemporaneous sites in the same region were occupied. The oldest human culture, the oldest human symbolic behaviour, and the oldest human genetic divergence all cluster in the same geographical zone with a consistency across independent data sets, archaeological, genetic, geological, that the phrase clustering understates. They are not merely near each other. They are within the resolution. The evidence permits the same place and the same moment triangulated from three completely different directions. What the southern African Gondwana suture zone represents in the combined record of all three traces is the specific geographical location where the conditions that Pangea and Gondwana produced the long unbroken biological continuity, the slow accumulation of ecological orientation across a connected surface, the deep mammalian cognitive development in an environment without ocean barriers, met the threshold at which a new kind of recording began. The ochre engravings at Blombos are not the beginning of human intelligence. They are evidence of a cognitive capacity that had already developed, already been selected for across a duration, and in an environment that the site's geological context encodes in its own way. The engraving is the record of the capacity. The suture zone is the record of the environment that shaped it. And the correspondence between them? The fact that the oldest evidence of the capacity appears precisely at the geological boundary where the connected world began. Its long process of coming apart is the pattern that none of the three established frameworks is specifically designed to address. The cognitive universalism argument explains what the ochre engravings represent: a universal human capacity for symbolic thought expressing itself in one of its earliest recoverable instances. It does not explain why that instance, and so many of the earliest comparable instances, cluster along the southern African Gondwanan margin rather than distributing evenly across the range of early modern human habitation, which extended well beyond southern Africa by 100,000 years ago. The plate tectonics framework explains the geological character of the suture zone completely without reference to any subsequent biological or cultural development. It does not address the correspondence between the zone's geological character and the distribution of the archaeological and genetic evidence. The oral transmission argument applied to the third trace is not directly relevant to a correspondence between rock formation dates and symbolic behaviour chronology. Each framework accounts for its portion, none accounts for the whole. The detail is smaller crosshatch pattern on a piece of ochre in a cave on a Gondwanan suture line 100,000 years ago, and it sits in the record with a specificity that all available explanations approach from their own directions without any of them arriving at the centre of it. Stay with this for a moment, not because it requires response, but because the pattern it describes the oldest recoverable evidence of the human capacity that makes civilization possible, located at the precise geological scar where the connected world's southern half first began to separate, is the kind of detail that the record produces without commentary, without instruction, and without any indication of whether its location is meaningful or whether it is the kind of coincidence that a sufficiently large dataset always contains. The silence around it is not a gap waiting to be filled. It is the question itself, in its most concentrated form, sitting in the cliff face above the Indian Ocean in rock that remembers Gondwana. The landscape from a distance. The cartographer Gerardus Mercator projecting the curved surface of the Earth onto a flat rectangle in 1569 made a choice that distorted every map produced from his system. For the next 4 centuries, he preserved the shape of landmasses at the expense of their relative size, enlarging features near the poles and compressing features near the equator, producing a world in which Greenland appears larger than Africa, when Africa is approximately 14 times Greenland's actual area. The Mercator projection was not an error in the sense of a miscalculation. It was a deliberate trade-off optimized for the navigational purpose the map was designed to serve, preserving compass bearing accuracy for maritime travel at the cost of representational accuracy for everything else. The distortion was accepted, became standard, and shaped how generations of educated people visualized the relative significance of different parts of the world in the ways that extended well beyond navigation into politics, into cultural assumptions about which regions were large and which were peripheral in ways that Mercator himself did not intend and could not have anticipated. The map served its purpose and created its distortion simultaneously, as all representational systems do. You cannot represent a curved surface on a flat one without choosing which kind of accuracy to sacrifice. The 3 traces examined across the previous chapters have a Mercator problem. Each trace, geological, genetic, cultural, is a projection of the same curved and complex reality onto a flat analytical surface optimized for the navigational purpose of the discipline producing it. Geology projects the Pangean record onto the flat surface of stratigraphy and isotopic chemistry, preserving accuracy about material composition and age at the cost of anything the rock cannot encode: behavior orientation, the slow accumulation of learned response to an environment. Genetics projects the Gondwanan record onto the flat surface of molecular divergence chronology, preserving accuracy about lineage, separation times at the cost of anything that does not leave a signal in nucleotide substitution rates. Comparative mythology projects the cultural record onto the flat surface of narrative structure, preserving accuracy about the formal features of stories at the cost of the specific geographical and empirical content those stories may or may not be carrying. All 3 projections are accurate within their domains. All 3 produce distortions outside them. The question is what shape the undistorted original has, what the curved surface looks like before any of the projections are applied, and whether the 3 flat representations laid alongside each other and examined for where their distortions diverge point toward a common original that none of them alone can show. Stepping back from the individual traces, to look at the whole landscape, the most striking feature is not the convergence itself, but the consistent direction from which all 3 traces approach their limits. The geological record is extraordinarily detailed about what existed and where and when, and becomes uninformative precisely at the boundary where biological and behavioral processes begin. The genetic record is extraordinarily detailed about lineage separation chronology and geographical dispersal, and becomes uninformative precisely at the boundary where learned behavior and transmitted knowledge begin. The cultural record carries information that in its oldest recoverable layers appears to encode specific geographical and environmental knowledge and becomes methodologically inaccessible precisely at the boundary where transmission history cannot be independently verified. 3 records, 3 disciplines, 3 projections, and all 3 reach their limit at the same conceptual boundary, the threshold between what can be read from material traces and what was carried in processes that do not leave material traces in any medium the available instruments can read. This is not a conspiracy of silence in the record. It is a structural feature of how information is preserved across geological time. Material processes leave material records. Cognitive and behavioral processes below a certain threshold of complexity and persistence do not. The Blombos Cave ochre engraving sit just above that threshold, the first recoverable indication that a process capable of leaving legible material traces was operating. Everything that happened in the cognitive and orientational history of the organisms inhabiting Pangaea before that threshold is in the strict evidentiary sense gone. The absence of evidence is not evidence of absence, but it is also not evidence of presence. It is simply silence, and the honest position is to acknowledge the silence as silence rather than reading it as either confirmation or refutation of anything. What remains visible after that acknowledgement is the landscape itself, and the landscape has a shape that is worth describing not as evidence but as orientation. The Appalachian and Caledonian mountain ranges mark one edge of the Pangean record geological material measurable undisputed. The Blombos Cave suture line marks another edge where the oldest recoverable evidence of the cognitive capacity that eventually produced the question we are asking tonight appears in rock formed by Gondwana's separation. Between those two edges, the genetic record of the lungfish and the ratite birds traces the biological continuity that connected them across 130 million years of accumulated divergence time. The songline system of the Australian continent itself, a Gondwanan fragment, describes in living practice what sustained orientation across connected terrain accumulates in cognitive form across generational time. These 4 reference points are not a proof. They are not even an argument in the strict logical sense. They are landmarks in a landscape, and their landscape they define as a shape that the question of what Pangea made possible fits more naturally than any of the available alternative explanations would predict without any of the evidence requiring that interpretation, rather than permitting it. Not proof, a pattern, and the pattern's most important feature seen from the distance this chapter requires is not its content, but its persistence. The geological record of Pangea's existence has been accumulating for 200 million years. The genetic record of Gondwana's fragmentation has been accumulating in living tissue since the separation began. The cultural records that may or may not carry traces of what that connected world permitted have been accumulating across whatever duration the oldest oral traditions have been maintained. None of these processes of accumulation was directed toward answering the question this episode is following. They simply continued, each in its own medium, each at its own timescale, each preserving what its medium preserves and losing what it cannot hold. The question arrived much later, carried by a species that developed on one of Gondwana's scattered fragments, looking back across the distance of 200 million years at a world whose shape is still readable in the rock and in the genome and in the oldest recoverable structures of human memory, asking what that world was and what it made possible, and whether anything of it remains. The question is the newest thing in the landscape. Everything else it is looking at is ancient beyond any useful comparison. The question beneath the question. At a certain depth of inquiry, archaeology stops being archaeology. The transition is not announced. It does not occur at a specific finding or a specific paper or a specific moment when the researcher looks up from the evidence and recognizes that the discipline's instruments have reached their operational boundary. It occurs gradually in the accumulation of unanswered questions that the evidence keeps generating at its edges, questions that are real and precise and clearly formed, but that no amount of additional fieldwork, no refinement of molecular dating technique, no more careful excavation of any site currently known will resolve. The question we have been following tonight reached that boundary several chapters ago, and has been operating beyond it since, not dishonestly, not by pretending the evidence extends further than it does, but because the question itself, properly understood, was always larger than the evidence that gave rise to it. The rock and the genome and the oldest recoverable cultural memories are not the question. They are the places where the question surfaces in a form legible to the instruments we have. The question itself is older than any of them, and it is not about Pangea specifically. It is about what continuity means, what it produces, what it permits, what it loses, when it ends across any scale and in any medium in which continuity can be said to exist. Philosophy inherits questions from science the way science inherits questions from observation, by taking them seriously enough to follow them past the point where the originating discipline's methods remain applicable without abandoning the rigour that made the question precise in the first place. The philosophical version of the question this episode has been tracing is not whether Pangea supported civilization in any documentable sense. That version of the question has been answered carefully and honestly by the combination of what the evidence shows and what the skeptic chapter established. The evidence raises the question without resolving it, and the simplest available explanation accounts for most of what the evidence shows without requiring any appeal to Pangean civilizational potential. The philosophical version is both narrower and deeper. What is the relationship between the duration of a continuity and the depth of what it accumulates? Not in biological terms, which evolutionary theory addresses at the level of genetic selection across generations. Not in cultural terms, which anthropology addresses at the level of transmitted practice across human timescales, but in the most general terms possible as a structural feature of how any sufficiently complex system operating within a stable and continuous environment across sufficient time develops orientation to that environment in ways that briefer or more interrupted engagement does not produce. The Buddhist philosophical tradition has a concept found in various forms across the Theravada, Mahayana and Vajrayana schools called dependent origination. The principle that all phenomena arise in dependence upon conditions, that nothing exists independently of the network of relationships that produced it, and that understanding any phenomenon requires understanding the conditions that gave rise to it, rather than examining the phenomenon in isolation from its history. This is not a mystical claim. It is at its most basic level a precise epistemological observation. The character of a thing is inseparable from the history of its becoming. Applied to the question this episode has been following. Dependent origination suggests that whatever cognitive and orientational character emerged in the organisms that developed on Pangea's connected surface cannot be understood in isolation from the conditions that produced it. The 300 million years of unbroken terrain, the absence of ocean barriers, the deep biological continuity of a world that had not yet learned to divide itself. The character of what emerged from those conditions is not separable from the conditions themselves, even if the conditions are no longer present, and even if the material traces they left are incomplete. This is where the question becomes cosmological, which is not to say it becomes speculative in the pejorative sense, but that it expands to the scale at which individual entities, organisms, species traditions, civilizations become features of a larger pattern, rather than primary units of analysis. The Earth examined at the scale at which Pangea is the relevant unit of geography is not a stage on which life performs. It is itself a process, an ongoing chemical and thermal and biological event 330 million years old in its Pangean configuration alone, cycling through arrangements of land and water and atmosphere that each produce their own conditions and their own consequences, none of which is the final or correct arrangement, and all of which are phases in something whose full duration and ultimate character are not currently knowable. The connected world of Pangea was one phase of that process. The fragmented world we inhabit is another. The next supercontinent, Amasia or Nova Pangea or Pangea Ultima, depending on which tectonic model you find most plausible, will be another, still 300 million years in the future when none of the current ocean basins will exist in their present form. And the Atlantic, which has been widening for 200 million years, will have begun to close. The ground beneath you is not still. It has never been still. It is 3 centimeters further from the ground beneath someone standing in Western Europe than it was when you were born, and it will continue moving in the same direction at the same rate for longer than the human species has existed on its way to a configuration that no human being will live to observe, and no current language has the vocabulary to describe. We will not resolve this tonight because resolution is not what this question is oriented toward. It is oriented towards a different kind of attention, the kind that does not require an answer, in order to be complete, that holds the open question as a feature of the landscape rather than a defect in the inquiry that finds in the gap between what is known and what the evidence keeps suggesting. Not frustration, but a particular quality of stillness. The Appalachian and Caledonian ranges are still made of the same rock. The lungfish genome still describes a continent that does not exist. The ochre engravings at Blombos are still on the cliff above the Indian Ocean in rock, formed by Gondwana's opening 100,000 years older than the oldest known writing system. These facts do not resolve into a conclusion. They resolve into a posture, a way of being oriented toward the deep past that does not demand it speak in the register of certainty that allows it to remain what it actually is. An enormous, mostly silent record of conditions that produced consequences still present in the world in stone and genome, and the oldest layers of human memory without any of those consequences being fully legible to the instruments we currently possess. The archaeology has become philosophy. The philosophy is becoming something quieter than either. What remains is one image, specific and material and very old, held in the dark above an ocean that did not exist when the rock containing it was formed. The cliff above the opening sea. The cave is still there. That is the first thing to hold before anything else is said, before any final observation is attempted, or any closing gesture is made. Bolombos Cave is still there in the limestone cliff on the southern coast of South Africa, 35 metres above the Indian Ocean, facing the water that opened beneath it, when Gondwana's southern components began their long separation, when the land that would become Antarctica pulled away from the land that would become Africa, along a suture line whose scar is the geological formation in which the cave itself is situated. The cave did not move, the cliff did not move, not in any duration a human life can register. The Indian Ocean continued widening at its floor, spreading rate of approximately 16 millimeters per year, as it has been doing for roughly 130 million years, pushing Africa and Antarctica incrementally apart along the same fundamental mechanism that separated them to begin with. The ochre pieces recovered from the occupation layer, dated to 100,000 years ago, are in storage at the Iziko South African Museum in Cape Town, 300 kilometers west along the same coastline. The cave is empty of them now, but the layer in which they were found is still there, still stratified in the correct sequence, still carrying the chemical and physical evidence of the fire that heated the tools, the shells that were brought up from the beach below, the accumulated presence of human beings who returned to that specific place on that specific coast above that specific ocean repeatedly and over long periods were, for reasons the archaeological record documents in material terms without ever fully explaining in human ones. What drew them back is not recoverable in any direct sense. The southern African coastal environment during that period offered reliable food sources, marine shellfish, intertidal organisms, the occasional stranded marine mammal in sufficient abundance to support sustained occupation, and the cave's elevated position provided shelter and a commanding view of the surrounding terrain in both directions along the coast. These are functional explanations, and they are almost certainly part of the answer. But the presence of the ochre engravings, the shell beads perforated for suspension and coated with the same ochre, the heat-treated silkrete tools whose production required a multi-step technological process involving controlled heating at temperatures above 250 degrees Celsius, all of this speaks to a community engaged in activities that exceeded the functional minimum in ways that the purely adaptive account does not fully absorb. They were doing something there that mattered to them beyond survival. What it meant in the terms it meant for the people who were doing it is not knowable. The ochre pattern is not a writing system. It does not decode. It is a mark made by a hand on a surface preserved in rock for 100,000 years, legible as a mark and illegible as a meaning present, specific and finally resolutely silent about its own significance. This is the image the episode ends with, not because it resolves anything, but because it concentrates everything. The suture zone beneath the cliff encodes Gondwana's fragmentation. The ocean visible from the cave mouth is the direct consequence of that fragmentation, the water that filled the space the connected world left when it pulled itself apart. The ochre mark on the stone was made by a human hand at the geological moment, not in geological terms, but in the terms of the question we have been following, when the cognitive capacity that eventually generates civilization language, symbolic thought, the ability to ask where we came from and what we once were first, became legible in the material record. All three traces converge here, the geological in the suture line itself, the genetic in the deepest branching human lineages whose ancestral territory encompassed this coast, the cultural in the oldest recoverable evidence for the kind of marking that all subsequent human cultures on every Gondwanan fragment and every other landmass would eventually produce in their own forms, in their own materials, for their own reasons, without any of them needing to have learned it from the others. The cave is the point where the landscape of everything the previous chapters examined becomes small enough to hold in a single image. What the image does not do is answer the question the episode opened. It does not establish whether Pangea supported something that deserves the word civilization. It does not confirm whether the oldest human traditions carry genuine transmitted memory of a connected world, or whether they reflect the universal architecture of minds that generate similar structures under similar pressures. It does not resolve whether the consilience of the three traces describes a real underlying unity, or whether it is the appearance of consilience produced by three separate elaborately explicable phenomena being examined together. The cave holds none of these answers. It holds only what it has always held: the mark, the layer, the cliff, the ocean, the long silence of 100,000 years between the hand that made the pattern and the eyes reading about it now. In whatever room you're in whatever light remains, in whatever posture, the body is found for the long passage towards sleep. Let the image rest there. The cave on the Gondwana suture, the ochre on the stone, the Indian Ocean below still widening by 16 millimeters every year, still moving along the scar of a separation that began before any mammal existed, carrying the two former halves of the same world incrementally further from each other across a duration that makes the 100,000 years of the ochre mark feel recent, almost proximate, almost like something that happened while you were looking away for a moment. The ground beneath you is a fragment of that same world still moving, still carrying in its geological structure the memory of what it was connected to before the oceans entered, and the long separation began. The rock remembers, the genome remembers. Perhaps the oldest layers of what the mind reaches toward in the dark, in the particular quality of attention that belongs to the edge of sleep, remember something too. Not as information, not as transmissible content, but as orientation. The faint structural trace of a time when the world did not end at water, when the horizon did not imply an ocean, when the unknown lay over land and was in principle reachable. You are already moving toward that edge. The cave is behind you now, and the ocean is very quiet, and the question does not require an answer tonight. It only requires the willingness to hold it open in the dark while the body grows heavier and the distance between waking and sleeping narrows to the width of a breath. Rest now, traveller. The Appalachian Mountains are still there, not as a conclusion, not as a final piece of evidence, but simply as a physical fact that was true before this episode began, and remains true now in whatever hour you are inhabiting. The rock in those hills carries the same isotopic signature as the rock in the Caledonians, as the same mineral memory of the same collision across 4,000 kilometers of ocean that is younger than both of them. Nothing that has been said tonight changes that. Nothing adds to it or subtracts from it. The mountain is the mountain. The ocean between it and its twin is still widening at the rate of a child's fingernail growing, and has been doing so for longer than the word for time has existed in any language. You can set down everything the episode raised, and the rock will still hold its formation angle in the dark. That is perhaps the most honest thing this series ever says about the deep past, that it does not require your understanding in order to continue. The Glossopteris fern was pressed into Gondwanan sediment 270 million years before anyone would think to look for it. The lungfish genome accumulated its divergence chronology across 130 million years of river pool afternoons in which no organism in the chain was aware of carrying a map. The ochre mark at Blombos was made and left and covered by subsequent occupation layers and compressed into the geological record across a duration so large that the whole of human civilization from the first fired clay to the present moment fits inside it without touching the sides. None of these things needed to be understood. They simply persisted in whatever medium they could persist in, waiting for an instrument sensitive enough to read them. We are apparently that instrument, imperfect, late arriving, working at the edge of what the available methods can reach, asking questions that the evidence raises, without answering in the specific register of attention that belongs to the hours before sleep. When the mind loosens its grip on certainty and becomes briefly willing to hold open questions, the way a cupped hand holds water, not tightly, not permanently, but with enough care that some of it remains when you open your hand again in the morning. You do not need to have resolved anything tonight. The three traces are still incomplete. The skeptic chapter's objections are still valid. The consilience is still ambiguous, genuinely irreducibly ambiguous in the way that the deep past is always ambiguous, not because the truth is hidden, but because the instruments do not yet reach it. History at this scale is not a story with a retrievable ending. It is a stratigraphy layer on layer on layer, each preserving what its medium preserves and losing what it cannot hold, the losses as informative as the survivals once you learn to read absence as carefully as presence. The connected world is gone in the sense that oceans exist now where land once was. It is not gone in the sense that the rock still aligns the genome, still branches at the correct moment. The oldest human markings still appear at the geological scar where the connection first broke. something persists. What to call that persistence, what to make of it, whether it speaks to anything about what the connected world accumulated and what the fragmented world inherited, those questions remain genuinely open, and that they will still be open when you wake, and that is as it should be. Perhaps the oldest questions are not problems awaiting solutions. Perhaps they are more like the suture line itself, permanent features of the landscape visible once you know to look for them useful, not because they resolve into answers, but because they orient you toward the depth of what the world has been. The cave on the Gondwana coast is dark now, and has been dark for 100,000 years since the last fire went out in the occupation layer where the ochre was found. The Indian Ocean moves below it in the old rhythm of water over stone. The Appalachians hold their angle in whatever weather is crossing them tonight. The lungfish breathes through its modified lung in a river that remembers nothing and carries everything forward anyway, the way rivers do, the way time does, the way sleep does, not by preserving the original form of things, but by continuing in the same direction across whatever distance remains until it arrives somewhere the departure could not have predicted. Let the body settle now. Let the questions find their place in the dark alongside everything else the mind carries into sleep, the unfinished, the unresolved, the genuinely unknown. The rock held its memory for 200 million years without effort. You can hold yours until morning. Rest now, traveller.